I will show you another way to compute the overlapping regions from this diagram. So basically in here, from the last time we only accept the customer within 7 km. Other than that, we will get rid of those. So, and then we use the convex method in order to compute the overlapping regions. We will have another method in here in this video for to compute as well. So basically, we just count the number of center for each customer, and then if the customer has more than one center in the count, and then we will uh, count the customer as the overlapping. Okay, let us do it. I need the summarize tool here, and then, okay, by the way, one more time, I just select everybody in the box, and then I just disable it to optimize the computational time. So by customer address here, I just group by, and then I will count the number of center uh, in this case. So I count the number of center. And then I can also combine the center names all together like a string, and then concatenate, and then uh, I will name it center list, and I use a comma to semicolon to center count, so that I know that how many center I have in this guy, and then also the name of the centers. Okay, so if I use the if I use the filter in this case to filter the guy with the center count greater than 1, then I will have the collision, and then I show you the result. Okay, so I think the other thing I need to into include in this computation is the location of the customer. So I take the first. In this case, the first and the last, they are the same. It's just the same customer, but then I want to see the location of the customer in lat long in the on the map. Okay, so hopefully after this, then there you go. So you can see later we can compare like for like the two solutions. Okay, I need to turn on the this box to compare like for like. But if you remember from the last video, and then you can see the result already. Okay, so this what does this say in the result? It says that in this guy in here, uh, this guy has can shop in two centers around. One is Bishan and the other one is Dover. This guy in here, okay, how can I say? Okay, there go. So this guy in the address is Bishan, shopping two center which are Bedok and Bishan. Okay, so basically this guy is in this area. So Bishan is here and Bedok is here. Okay, so uh, so in this case, you have a detailed version of uh, what is it the overlapping region. But then uh, in order to produce the boundary for this one is very challenging. Okay, so you have the points, you have the very detailed point, and you can tell the location of the customer as well. But how to draw the boundary in here and then in here, it will be very challenging. So that's why we need to combine the two solution at the same time. And then in this case, I will show you the combination. I will use the union in here, and then I will combine the solution from here to here. Actually, I think I only need from here because I don't need further detail. I just want to show you the picture of the tool. And there you go. So you can see all the guys I want to select is within this region already. And then they are like, if you want to zoom to see the details, you can zoom a little bit. Uh, this is not a convex hole. This one looks like convex, but this one doesn't. This one confirm is not a convex whole of the whole population. But the trick is by using this method, you can actually draw the boundary, uh, the boundaries of the points. If you okay, let me show you the convex anyway. So okay, how to actually I also don't know how to draw the convex boundary in this situation, because if you want to draw the convex, it has to go with all the points. So it will draw the convex hole in all the points in here. It's not like the left part and the right part. Oh, actually, somehow I can draw it, and let me show you the. It will work in this case only, but it doesn't work in general. So the trick is I copy the point in here, and I know that this one is 0.3 something, and I would use this longitude to spread as to split this into two, and then I compute the bounding box for the two. So that's the only trick I can think of at the moment. Okay, so let me do it. So I will use the uh, I will use this one as the group or tag, and I copy the point in here. So if the center x of the C point is smaller than this amount, then I will put it A or west. Okay, so it's west. Actually, you can put A or B or so else east. Okay, so if you want to, you can A west and B east. So the same thing, but the point is we can divide the set into two, and then now I can compute the bounding box for two of them. Okay, so in here I will combine a group by the tags, and then I combine all the points from the tag together in the I can use combine, but I would let us use the convex in this case. So how, and then I will connect this one back to the result. Okay. Uh, okay, so I'm a little bit confused because why the convex is so big like this. Oh, sorry. Because I count the everybody inside the region. So I only count the guys with in the collision the collision or the overlapping region, not everybody in the population. Okay, so let us fix the. Okay, so there you go. So you can see this the purple one here is the bounding box of the west, and then this one is the bounding box of the east. And you can also, oh, by bounding box is I mean the convex hole. Bounding box is actually the rectangular shape, but in this okay, so let us compare the two in this case first. On the west, you can see here this overlapping region by the intersection method actually give us something like this, but the bounding box just give us something like this. So it's a little bit smaller. This thing happened because you have the two circle, or you have to the two big circle to intersect, and then it can draw something intersection in between. But actually, this point doesn't exist in the population. It's just because of the intersection method of the two circles, or in this case, the three circles. That's why this point is here. But there's no population in this area. Okay, so let us go to the other the place, and then we. Oops, sorry, wrong guys. Okay, so we have the same thing. The bounding box is this one is the overlapping region formed by the two circles. So it's a little bit bigger, but this one is the bounding box. So this the inner one is the bounding box, and then it's very fit to the population, like no extra regions. Then all the and we have the customer points in all the in all the boundary of the convex hull. But this one, because of the intersection between the two circles, so we have the like the point something around here and something around here, just because of the circle, not the actual boundary. Okay, so hopefully after this, after the two methods to compute bounding box, sorry, overlapping regions, and then bounding box of the overlapping regions. I hope you understand the concept, and then more importantly, after you understand the concept, you can apply to your commercial application. So for example, if you want to compute the overlapping region to see if it is very big or very small. If small, then you can ignore. If big, then you have to do something about it. You have to fix it in order to minimize the collision area. Otherwise, you have to compete with other guys, or you have to compete among yourself within the store network.